So hello students, today we are going to discuss about the trickling filters, right? So we already know that there are two main processes in the biological treatment of water, wastewater, right? So we have in the biological treatment, right? So we have two things, two types of treatments. One is suspended growth process, another one is attached growth process, right? So suspended growth process where the microorganisms and food material are going to be in a suspension, but for the attached growth process, the microorganisms are going to stick, right? It is going to attach to a particular inert surface so that the wastewater is going to get, what we can say, treated during that passing, right? So now, till now we discussed about the suspended growth process, like active research process. Then we have the oxidation ditches, oxidation ponds, right? So aerated lagoons, everything we saw till now. Then we are going to see about the attached growth process, right? So attached growth process. In this process, microorganisms are responsible for conversion of organic matter present in the wastewater are attached to some inert medium, right? So here the microorganisms are going to be not in a suspension. If we take this kind of inert material, right? So this around this inert material, the microorganisms are going to be attached, right? So a layer will form. Okay, this is called biofilm. What is called biofilm? Okay, so if any wastewater is going to pass over this, right? So if any wastewater, right? So if wastewater is going to pass over this, right? So this wastewater may contain small organic compounds. That organic compounds will absorb by these microorganisms, so that the biofilm thickness will get increases, right? So that the biofilm thickness will get increases, so that the wastewater get treated. Okay, that's what is telling. The conversion of organic matter present in the wastewater, right, are attached to the some inert medium. The microorganisms are going to attach to some inert medium such as rock, slag, then ceramic or plastic material. This process, okay. So based on this, we have these main 5 types of treatment units. That is contact beds or contact filters. Then we have intermediate sand filters. Then we have trickling filters, rotating biological contactors, that we simply can call it as a RBC. Okay, so what we can say, we will call it as RBC, right? So next we are having the fluid bed reactors. Okay, in our syllabus we have mainly this contact bed filters, trickling filters, and this one A, C, D. Now among these, the important first thing in today's class we are going to discuss about the trickling filters, right? So even we are knowing about the suspended growth process. Here the microorganisms are responsible for conversion of organic matter present in the wastewater maintained in the suspension. That means it is not going to attach to a fixed surface, it is going to be in a suspension, right? So with the liquid in the reactor, by employing the natural and mechanical mixing, so we are going to mix it, right? So based on this purpose, we know active such process is there, oxygen ponds are there, aerated lagoons are there, we already know this, right? So let's coming up regarding the trickling filters, right? So these are also called as percolating filters or sprinkling filters. Okay, so here it is like a filter media, right? Like a filters what you observed in the drinking water treatment, right? So you will have a tank, enclosed tank. Okay, so this enclosed tank at bottom we are going to have the under drainage system. Then above this we have gravel. Above this we have the gravel. Okay, this gravel is called filter media. This gravel is called filter media. Okay, exact at center we are going to have the rotor, right? So the wastewater will be fed from the center, right? So here we have a rotor mechanism. It is going to rotate, right? So this rotor mechanism is going to make the water trickle down, right? It is going to, like a raindrops, it is going to fall, right? So when these raindrops are coming over this media, right, we already know that around this media. Okay, so we are going to have the biological layer. We are going to have the biological layer, right? So with that biological layer, okay, if everything will have a biological layer, right? So whenever the wastewater is going to come here, right? So wastewater is going to pass through that. The food which is as a waste that can be absorbed by the microorganisms present in this biological layer, right? So that the clean water will move down, that will be collected in the under drainage system, and that will be sent out, right? So if this process is continued, after some time the thickness of this layer will get increases, and some point of time it is going to what is called shear off. That means it is going to removed, right? So again the sludge will come down, and we are going to take this effluent from this trickling filter, and we are going to make settle out in the secondary sedimentary tank whatever thing we kept in the case of activated sludge process. Same thing will do here, right? So this we can say regarding this trickling filter, right? So consists of a tank of coarser filtering media. It is a tank. It is having a coarser filter media over which sewage is allowed to sprinkle or trickle down, right? It is going to sprinkle over this media, so it has to be moved on by means of spray nozzles or rotary distributors. We have the rotary distributors or spray nozzles. If it is a rotary is there, when it is a round circular one. If your tank is a rectangular one, there we will use the spray nozzles, right? So the percolating sewage is collected at the bottom of the tank through a well-designed under drainage system, right? So we have a well-designed under drainage system. Then we are going to discuss about the principle now, right? So without reading these sentences, I am going to explain you the whole process now, right? So let us see if this is the box, okay, tank, right, where we have under drainage system here. Above this we are going to have the filter media, and center we are going to have the inlet for wastewater. This and all filter media, right? So from where the water is going to spread over this. This will come like this, right? It will get spread over this. Then finally it will reach us to the under drainage system, right? So now we have a inlet and we have a spray tower. We have a tank here, and we have media, and we have a under drainage system, right? So this like the operation will be like this, but we have to see what exactly is going to happen inside the trickling filter, right? So now we will see. First, I'm taking a okay, some stone, right? Inside it is a coarse aggregate which is in the filter media. In the initial stage, the first stage, it is as pure without having any dust. With the cleaned coarser grain, we are going to keep it there. When the wastewater is passing over this, right? Slowly, with the help of microorganisms, already it is there in the wastewater, is going to attach to this particular inert material or rock, right? So what happened now? Thus microorganisms are going to form the layer around that, right? It is going to form the layer around it, okay? Layer around it, right? So that layer will be like this, small layer will form, okay? For the next case, again around this we are going to observe the the layer thickness is going to become more, right? See, it is very small. Continuously wastewater is coming. Continuously wastewater is coming. This is the first case, this is the second case, and this is the third case, right? So since the layer is going to become bigger, then now I am going to take off this part. Let me explain about it. If I have that part, I am going to have this much thickness of layer, right? So over this we are going to see the flow of wastewater, right? So this is the flow of wastewater. This is the inert material, right? So if thickness is increases, the layer called biofilm or biological layer, right? So the whatever oxygen and food material coming along with the wastewater will be taken by the bacteria which is present near the surface, right? Near the surface we will have all conditions. Those are in aerobic. And if you coming from outside to inside, the oxygen level will get decreases, right? No oxygen will be get, and no oxygen food will get by this bacteria. Some may be facultative and some conditions may exist anaerobic, right? So if you are maintaining those kind of anaerobic and facultative things, the surface contact between the inert material and as well as the surface contact is there, no? So this surface contact is going to be loosened, right? So why? Because at this point, at this particular point, the microorganisms doesn't get any food or oxygen. Because of that, it is going to die. Once it is got die, due to the force of water which is coming from top to down, it will have some action, shear action over this, so that the layer will get removed and it is going to fall down in the bottom of the tank, right? So once it is fall down, again the fresh kind of this kind of aggregate will be exposed again. Then layer will increases. Once layer increases, lower inside microorganisms won't get any kind of food and oxygen because they are going to die. So that the layer is going to peel out, that is going to remove out due to the action of water, right? So this is the actual thing which is going to happen in the case of trickling filter, right? This is main principle behind this. Next we will read one by one sentence. You can follow me. The decomposition of organic matter under the resultant, right? So under the resultant purification of the sewage is brought about by a population of microorganisms. Here the treatment will be done by the microorganisms. Microorganisms and bacteria which are naturally present in sewage get attached to the filter media, right? It is going to attach to a filter media. Okay, so we already know that. So we have a filter media. This filter media is going to be attached by the microorganisms. Next, organic matter from the sewage influent is also absorbed on the biological film, right? Whatever microorganisms layer is there, that is called biological film, right? So the organic matter which is coming from along with the wastewater is going to be absorbed into the biofilm, which is formed by the microorganisms around the filter media. What is that? The film is formed by the microorganisms around the filter media particles. In the outer portions of this film of the biological mass or slime layer, the organic matter is also degraded by the aerobic bacteria. The bacteria which is in this slime layer or biological layer is going to it is going to absorb the food material from the wastewater. Next, as the microorganisms grow, the thickness of slime layer will be increases. The biological layer or slime layer is going to be increases, and diffused oxygen is also consumed by the upper portions of the slime layer. Whatever it is there on the outer surface, total oxygen food will be taken by those things, but thereby creating an anaerobic environment near the surface of the media particle. If you only the microorganisms which are at the outer surface is going to get all oxygen, So whatever inside near to this what is called inert material, no? So there we have the anaerobic conditions. Outside we have the aerobic due to the oxygen absorbed will be here and less will be sent inside, right? So next, as the slime layer increases, the absorbed organic matter is metabolized before it can be reaches the microorganisms near the media phase. This creates shortage of external source of organic carbon near the media phase, so that no food, no organic matter will be sent near to the inside, right? So due to which the microorganisms near the media phase enter into an endogenous phase. Endogenous phase means it is a death stage and the final stage of the microorganisms where of growth and lost their ability to cling to the media surface. If it is going to be endogenous phase, that is in a death phase, right? Death phase, right? So due to that, it is unable to stick onto this inert material, right? So next, the liquid seaway exerting a shear action. Since I told that, okay, for water which is coming from the top is going to do the shearing action, then so the layer can breaks some biological mass or slime layer from the media, but the new slime layer will continue to grow. Once it is removed, then again new slime layer is going to develop, right? So the continuing growth and breakup of biological mass from this biofilm in fact create a balance in the thickness of the formed biofilm, right? So whatever biofilm is or slime layer is formed here, it is going to create a balance in the thickness of the formed film. Next, the breakup or detachment of biomass from the slime layer is called as the sloughing, right? So the breakup, the removing due to this shear action, the removal of the biological film or a slime layer is called, okay, the thing is called sloughing. This is the very important for 2 marks question in the JNTK examinations, right? The sloughing is in fact imparts stability to the filter effluent and the sloughed material is separated from the treated sewage in the thing called secondary settling tank. So trickling plant along with the trickling plant it may be attached with secondary settling plant tank where this kind of slim layer is going to be removed. That solids will be removed by settling. Okay. So in the construction of trickling filter, we have main 4 parts. The first one is watertight holding tank. This holding tank may be a rectangular or circular one. Then we have a distribution system, that is rotor system, right? So it is going to sprinkle the wastewater over the media. Then we have the filter media to have the treatment of wastewater. Then we have the to collect those treated wastewater from the trickling filter. At the down we are going to have some collection system. So that is called under drainage system. Okay, let us see one by one. The first thing you can see here. Here we are going to observe the all filter media where we have a circular one. This is a circular trickling filter. So at the center manifold we are having, and here the water will be entered here in the middle, and it will be supplied to the all these 4 arms, right? So these 4 arms you can see here, the water is going to trickle over this. The wastewater is trickled over the media, and it is going to be rotated like this. Okay, once it is passing through this inert material, it is going to be treated with help of microorganisms, right? So next, see. So this is very full photo, right? Central rotor will be there where we kept motor, right? Electric motor, so that the arms are going to be rotated along with the circular surface, right? Next, this is the line diagram of trickling filter where the feeding water, the raw water will be entered here and it will lead us to center portion. From here we have a rotary distributor. Here we have some electrical motor. With help of that, the rotary distributor is going to rotate. Okay, once it is reached here, then it will be distributed in all the arms. From there it is going to be trickle down, right? So once it trickle down onto the inert material, so it is going to form the slime layer and it is get sloughed. So finally the things will be collected at the bottom with help of a under drainage system, and that will be taken for the next treatment, that is called as the secondary settling tank. There we are going to remove all these slugs, right? Slugs whatever formed here like a slime layer, right? So that is going to be removed, right? Next, so the tank is either, like first of all we are going to discuss about the tank. The tank is either a rectangle or square one, right? So it may be a rectangle like this, or it may be a circular one, right? So rectangular tanks will have a fixed nozzles, right? Fixed nozzles. With help of these nozzles, the wastewater is going to spray over it. But in case of a circular tank, right? So we will have a some rotary distribution system. Okay, so this rotary distribution is going to rotate. It is going to be rotate like this in a clockwise and clockwise direction, so that the wastewater is going to spread over the media, right? So a rotary distributors are here. You can see rectangular or square. If fixed nozzles are used, right? Square or rectangular will be used with the fixed nozzles like this, but for a circular shape, we are going to have the rotary distributory, right? Rotary distributory are used. Okay, so a rotary distributors are made more reliable and easy to maintain and operate. Okay, since this compared with the rectangular one or square one, circular thing will be very easy and it is having very less maintenance and operation things. That's why we are going to use the circular shape is most commonly used. The distributor rotates around the central support either by electrical motor or more generally by the force of reaction of spray also it is going to be rotated, right? So the rate of revolution may vary from 1.5 to 2 revolutions per minute. Okay, very slowly it is per minute is going to rotate around 2 rotations, right? So the rotor arm should be remained about 15 to 20 centimeters above the top surface of the filter media. Above the filter media it is going to be located. Next, the walls are either masonry or concrete. The tank walls are either constructed with masonry or concrete. Next, the walls are constructed such that they should withstand the pressure exerted by the sewage from inside, right? It has to hold the media as well as it has to withstand the pressure which is given by the sewage which is present in the trickling filter. Okay, so the walls are made watertight, no leakage should be there. Next, it also consists of a filter medium which should be have a specific surface area, have high percent of white spaces, resistance to abrasion and insoluble in sewage water. Okay, next we are going to discuss about the filter media. So the filter media consists of coarser materials like cubically broken stones, or we have a slag, right? So the size of the material vary between 25 to 75 mm. It is very big size, right? So next, nowadays a plastic media instead of stone media is also be used with a size of 25 to 100 mm. Okay, so now here we have some important things, that is hydraulic loading rate and organic loading rate. Now we are going to discuss here. For hydraulic loading rate, for high rate plastic media filters we have 40 to 200 meter cubes per meter square per day, right? So for high rate stone media we have 10 to 40 meter square per meter, 40 meter cube. Okay, so per meter square per day. Okay, so now the depth of the filtering media may vary between 2 to 3 meters only. Next, the media placed in layers with the coarsest stone used near the bottom and finer materials towards the top. Okay, so now same principle what you used in the case of filters, in the case of drinking water system, right? Same thing, right? So the big particles, the big aggregates will be kept at down and the smaller particles will be kept at the top, and it is going to maintain a layer by layer. Okay, next, below the media we have the under system. It is going to supported by the floor which slopes at 0.5 to 5%, okay, to a collection channel. Okay, so all things will be coming to the common point where we are going to collect the treated sewage, right? So now you can see here, so this is the line diagram of the what is called trickling filter. So where this is the inlet, through this water will be entered to the central manifold. From this rotary distribution system, it will be sprinkled over the filter media. Okay, so once filter media is going to pass through the filter media and it is going to have collected by the under system. These under system will have some 15% of slope and it will come towards the center part, from where the effluent will be taken out and it sent it to the secondary sedimentation tank, right? So here you can see. Next, the sewage is allowed to sprinkle over the filter media through the nozzles or rotary distributors that we know. The biological purification is mainly done by the aerobic bacteria, which forms a bacterial film known as biofilm or slum layer around the filter. media. Then this biofilm layer is aerobic only up to a depth of 0.1 to 0.2 mm, and the remaining part is anaerobic, right? So we know around that layer, out of that 0.1 to 0.2 mm only aerobic, remaining will be anaerobic. Next, the organic matter is degraded by aerobic microorganisms on the outer portion of the biofilm, right? So the organic matter is going to degrade with the help of aerobic bacteria only, right? So now we can see in this figure, so this is the bed media. Around this we have a microbial slime layer, biological layer, right? So outer layer is to be aerobic and inside layer will be anaerobic, okay? So only food and food and oxygen is going to get by this kind of layer bacteria. Inside we don't have, it won't get any food and oxygen, so that it will get what is called loosened, and it will be move along with water. That is called, process is called sloughing. Here wastewater will come, right? See, air will be there, CO2 will come out, and other oxygen products will be come out. This wastewater will be come here, and treated water will move out of this process. Okay. Next, the food concentration is high at the outer surface of the biofilm. Hence, the growth of microorganisms is more at the outer surface of the biofilm. Obviously, outer surface is going to increase daily. Okay. The most diffused oxygen is consumed by the microorganisms at the outer surface before it reaches to the depth, right? So once it is going to be reaches to depth, the oxygen and the food material will be extracted by the biofilm. Next, hence the anaerobic environment is developed near the inner surface of the biofilm. That thing we know. Next, so see here, this is the filter media, this is anaerobic layer, this is aerobic layer, right? So this is only going to get all food and as well as the oxygen, right? So this won't get any oxygen, and it is going to be die, and automatically it is going to get removed, right? Eventually there is scouring of slime layer due to the flowing liquid, and fresh slime layer begins go on the media, right? That will go, new layer will get form again, and that will also be removed after some time, then new layer will come. Okay, this cycle is continuous. The phenomenon of scouring of slime is called as the sloughing or unloading of the filter. This is very important definition. Please remember, sloughing is the scouring of slime layer or biological layer in the trickling filter. The effluent from the filter is then taken into a secondary sedimentation tank for settling out organic solids oxidized while passing through the filter. Next, with an organic loading, okay, so next we are going to see the design of the trickling filter, right? So in the design, it is going to involve in the to find the diameter of the circular filter tank and depth, right? Or mainly we are going to see two things we need to do. That is, one the diameter, another one is the depth, right? So it involves, the design involves in the design of diameter of circular filter tank and its depth. The design of rotary distributors and underdrainage systems is also involved in the filter design, right? So the design of filter size is based upon the values of filter loadings, right? So two types of filter loadings are there. One is hydraulic loading rate, another one is organic loading rate. Okay, so this hydraulic loading rate is expressed in terms of million liters per hectare per day. Million liters per hectare per day. Okay, so this value will be 2244 for the conventional trickling filters and 110 to 330 for high rate trickling filters. Then coming to the organic loading rate or volumetric loading rate, here it is expressed in terms of kg of BOD per hectare meter. Kg of BOD per hectare meter of the filter media, and it will, the values are ranging for 900 to 2200 for conventional and 6000 to 18000 for high rate trickling filter. Okay, next, with an organic loading, find the total volume of the required filter, okay, and deciding the total BOD of the sewage. Okay, so we are going to decide the total BOD rate, loading rate. So based on that, we are going to know the volume of the filter. Next, hydraulic loading rate gives the area of the filter when total volume is entered divided by the hydraulic loading rate. If you divided this, we will get the area. Okay, so where we will get, first of all, meters cube of volume here and meter square of area here. Okay, so if you know this, we can find by knowing the volume and area the cylindrical filter, we can easily find out its diameter, and we are going to find out its even depth also. Okay. Next, advantages of trickling filter. The rate of filter loading is high. Okay, so very high, requiring very less land and smaller quantities of filter media for their installation. Next, effluent applied from the trickling filter is sufficiently nitrified and stabilized, right? So they can have about 75% of BOD and 80% of suspended solids. Hence, the effluent can be disposed of in a smaller quantity of dilution water. Okay. Next, working of trickling filter is simple, does not require any skilled supervision, and they are also self-cleaning. Mechanical wear and tear is small as it contains very less mechanical equipment. Then they are flexible in operation and can withstand the applications of variety of seaways having different concentrations and the compositions. Okay. Next, moisture content of the sludge from the trickling filter is high as 99%. Trickling filters are efficient in warm weather and produce an effluent of lower BOD. Okay, so they are of immense use in the hot countries like India. Right. Next, disadvantages. Okay, here head loss through the filter is very high. Cost of construction is very high. Okay, so these filters cannot treat raw seaways and primary sedimentation is must. Okay, primary sediment is a must. This process may develop odor and fly nuisance. Okay. Next, we are going to see about the operational troubles or nuisances in the trickling filters. Mainly, we are having the three things, that is fly nuisance, odor nuisance, and then ponding trouble. Let us see one by one. The first thing is fly nuisance. Fly means, okay, the creatures, right? The filter fly or cycoda which develops in the filter particle may prove to be nuisance, right? Here, this problem may be controlled by flooding the filter with the seaways for 24 hours or more. The flooding will destroy the larvae, right? So, however, 2 or more filters will be needed in order that one is flooded, another is available to treat the seaways. Okay. Next, another method of controlling fly nuisance is using the insecticides. That is some kind of insecticides we are going to use to kill that. That is called like a DDT, dichlorodiphenyl. Okay, so trichloroethane or chloridans, right? Then and I have benzene, hexachloride, etc. These kind of the chemicals is going to spread to kill the cycoda. Next, flies may be developed some resistance to one particular insecticide. In such case, insecticide must be changed. Right. Next, insecticide may be applied at siphon chamber or at any other places which is convenient. Okay. So the dosage of insecticide is normally 1 to 2 mg per liter based on total daily seaways flow is applied over a period of 2 hours. We need to apply to kill that. Okay. The second thing, is odor nuisance. That means bad smell, right? So odors are generally not prevail in the rotary distribution, but when its fixed nozzles are used, H2S and other odorous gases are frequently released from the sprays into the atmosphere, right? So usual remedy is to chlorinate the seaways to prevent the formation of H2S. Okay. Some odors may be evolved due to sludge and also due to the anaerobic conditions, right? So the remedy is to keep the seaways fresh in a recirculation. Next, coming to the third one, ponding trouble, right? So the voids in the filter media gets clogged due to heavy growth of the algae and fungi and results ponding of the seaways over the filter media, right? If it is clogged, every holes, that is called space, no? So automatically the ponding will occur. Okay. So this trouble can be controlled by chlorinating the seaways, which kills the algae, thus causing unloading of the material, right? So another method in controlling, okay, is adding copper sulfate also will be added to control the algae growth even in the ponds also, right, to the seaways and resting the bed for some time. Okay. Next, types of trickling filters. This is very important. So there are classified based on accordingly organic or hydraulic loading rates, Based on that we have high rate and low rate. Okay, according to the number of units used in series. Okay, so the first thing, according to the organic and hydraulic loading based on this, we have standard rate trickling filter or conventional trickling filter, we have high rate trickling filter, and we have a roughening trickling filters. Then coming to the, according to the number of units used in the series, based on that we have the single stage trickling filter and double stage trickling filter. Okay, let us see one by one. First one is standard trickling filter, whatever you saw in the previous diagram. So same thing will be having, that is conventional standard rate. Here, these are relatively simple treatment units, normally produce a consistent effluent quality even with varying influent strength. Okay, so there might be also generally not provided with recirculation of the effluent. Okay, so depending upon the dosing system, wastewater is applied intermittently, right? You have to apply intermittently. With proper loadings, these filters including primary and secondary sedimentation units should remove from the 80 to 85% of the applicable BOD, right? So nearly very good efficiency is there. Now coming to the high rate treatment filter, right? So where we have so much water is getting to be treated, what is going to happen here now? So the influent which is coming to the treatment filter will be treated and it will be collected in the thing and it will be settled, the sludge make settle in the secondary treatment, secondary settling tank. From there the supernatant liquid will be taken and it's going to be recycled. Okay, so that the removal rate will be more. Okay, so when recirculation is used, okay, so this is called, again the treated sewage will be bringing back to the plant, what is called treatment. Okay, so that's why recirculation is used. The hydraulic loading rate per unit area of the filter media is increases, right? So as a result, higher flow velocities will be usually causing a more continuous and uniform softening of the excess growth, right? So high rate trickling filters including primary and secondary sedimentation should under normal operations can remove only 65 to 85% of the BOD, whereas conventional is going to remove 80 to 85% of BOD from the wastewater. Then coming to the third one, roughening trickling filters. Okay, so these are also called as super rate trickling filters and bio towers. Okay, bio towers. Roughening filters are high rate type of filters designed with the plastic packing, right? So in the most case, roughening filters are used to treat wastewater prior to the secondary treatment. Okay, so that is ahead of existing trickling filter. We are going to use some kind of filter before to the secondary filter, and that means after primary treatment, right? So before secondary treatment, we are going to provide this type of things are called roughening filter, trickling filters. Even roughening filters are there in the case of drinking water treatment, where we are going to keep some slow sand filter, what is called rapid sand filter before the slow sand filter, so that the things will be removed properly, right? So these filters are used for treating waste waters with very high BOD. Whenever high BOD is there, you can use some another extra one. Okay. Next, low energy is required for BOD removal of high strength wastewaters as compared with the active sludge process, because the energy required is only for pumping the influent wastewater and recirculation flows. Okay. Next, the diameter of bio towers may vary from 3 to 70 meters, and these walls can be made up of RCC. Then air blowers may be provided to handle high organic rates. Okay. Next, coming to the based on the series which is using, right? We have single stage trickling filter. Here only one single filter is adapted. When two or more filters are required, they will be provided in the parallel, right? So here we have a primary settling tank. After primary settling tank, we have the trickling filter with arms, spraying arms are there. Okay. After that, we have the secondary settling tank. Okay. So generally, recirculation is not provided here. Okay. So then coming to the next double stage trickling filter. Here, the system consists of two filters in series, where recirculation of effluent is normally adapted. There, in the single stage, no recirculation. In the double stage, we have the recirculation, right? So this recirculation of the treated sewage in the high rate trickling filters, right? Recirculation consists of returning of the portion of the treated or partially treated sewage to the treatment plant, or the treatment water will be bringing back, right? Usually the return is from secondary settling tank to the primary settling tank or to the dosing tank of the filter, right? So wherever you want, you can bring it back from the secondary sedimentation tank to the primary sedimentation tank or to the, okay, so if you are having the primary sedimentation tank, we have the trickling filter and we have the secondary sedimentation tank. From here it may taken to the before to the primary sedimentation tank, or it will be bringing back to the trickling planter, next simple thing. Okay, next, single stage commonly adopted recirculation process. Here you can see this is the trickling filter. After secondary heat clarifier, see the recirculation may bringing back to the influent of the primary clarifier, or it may be bring back to the here also. This is a alternate return. Okay, alternate return. Next, in some cases a two-stage circulation process is may be adopted. Okay, a two-stage recirculation process consists of having two filters arranged in series, right? So various combinations are possible, right? Here we can see, okay, influent is coming here through the primary clarifier. We have first stage trickling filter. From after this we have again recirculation. Then we have the secondary sedimentation tank, okay, of the first stage. From here we have the second stage trickling filter. Then we have secondary clarifier. Even from secondary clarifier also it is coming, bringing back to the again second stage. Like this we have the two stages here, right? So here some improvement are due to the recirculation. Okay, so what improvement is there if you are doing the recirculation of wastewater in the case of trickling filter, right? So recirculation allows continuous dosing of the filters irrespective of the fluctuations in the flow. There won't be any there will be any fluctuations, but we are having the continuous flow. Next, recirculation equalizes and reduces the loading and thereby increasing the efficiency of the filter. Recirculation will increase the efficiency of the filter. Then recirculation provides longer contact periods of the applied sewage with a bacterial film on the contact media and accelerating biological oxidation process. Right? The influent remains fresh at all the time and also helps in the reducing water solubility reduced. The fly nuisance also comparatively less, but the effluent greatly reduced BOD content because recirculated flow nitrification process have not completed efficiently, slightly lowering the quality of effluent. Okay, so now the aerated filters are mainly three types. Okay, so one is biofilter, okay, axolo filter and aerofilter. Okay, so this is out of our syllabus, right? So if you want, you can buy things about this in a standard textbook. Okay, so that's all about trickling filters. In the next class we are going to discuss about the protecting biological conductors. Thank you.